Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. So if you have been liking the kinds of videos that I make, maybe you should consider subscribing to the channel, and you can follow me on Twitter as well. In this particular video, we are going to look into how we can deploy a client Go application inside a Kubernetes cluster. When I say a client Go application, I mean an application that talks to Kubernetes API server to do certain things. For example, in one of the previous videos, we have written a very simple application that makes a request to Kubernetes API server to list pods and deployments from default namespace, and we were able to do that by using these libraries, client go libraries that Kubernetes community and contributors provide or maintain. So if we quickly have a look into how that very simple application looks like. So for example, let's say we have this Kubernetes cluster, and we set up this Kubernetes cluster using kind. So even though this cluster is running on my host machine as a container, let's assume, our application was not running inside Kubernetes cluster. This application that we wrote in one of the previous videos was actually running on the host machine itself. And this application that we have written, this application was getting the details of Kubernetes cluster by looking at the kubeconfig file at its default location. So this is what we were able to do in the last video. In this particular video, we are going to look into how we can get this application and deploy it inside Kubernetes cluster. Now, if we talk about deploying an application inside Kubernetes cluster, because Kubernetes is a container orchestrator, we will have to containerize our application. So earlier we were just running this Go application using the binary, but now we will have to containerize that so that we can get that deployed on Kubernetes. So let's just go ahead and try to look into the application that we have. So this is the exact application from the previous video. What we have done is I have just renamed the application to lister, and I have also changed the module name to lister. That is all. And if we talk about this main.go, this particular file is exactly what it was in the previous video. Now, before actually containerizing this application, let's just go ahead and try to improve it a bit. Just printing these error messages that we commented out. So if we were not able to build config from flags, we just want to, let's say, print that there was an error building config from flags, and the error was this. Similarly, if we were not able to create client set, we can specify that there was an issue creating the client set, and this is the error that we had. And one more time, here we can have the same format. For example, error this while listing all the pods from default namespace, and this is the error that we have. And we are also listing deployment here, and if this particular error is not nil, it simply means that there was an error listing the deployment. Now that we have improved this, let's just go ahead and try to containerize this. So what I'm going to do is I'm going to build this, and as soon as we have built this and we have a binary, we can create a Docker file to actually containerize that application. So Docker file, and in this Docker file we can containerize this application in a lot of ways. But for example, we can have the steps to build the Go application in the Docker file itself, or we can build the binary separately, and we can just copy the binary over in the Docker image. So yeah, I mean, it's not, I'm not trying to explain what is an ideal way to containerize your Go application. So yeah, I mean, just this is just a way to do that. I'm not saying that this is how people do it. So let's say I want to use Ubuntu as base image, and let's copy over lister to lister, and entry point for us is going to be lister. So it simply means we are using Ubuntu as a base image, and we are copying over the lister binary that we have just created as the output of go build command, and we are copying over that binary inside the Docker image, and we are setting entry point to be lister. So as soon as someone runs our container image, this is the command that is going to be executed. Now if I just go ahead and try to build this, let's say lister colon 0.1.0, this should be built in a second. And as you can see here, this is the Docker image that we have now. So to get this image deployed on a Kubernetes cluster, we will have to push this particular image to a container registry. So let's push it to my container registry, and to do that I'm going to tag it with my username, and then push it to my container registry, or Docker container registry, I would say. So as soon as this particular image is pushed, we can create a deployment in Kubernetes cluster with this providing this particular container image. And as soon as we create the deployment, we can say that now our application is running inside Kubernetes cluster. So if I try to explain that again, maybe, so this is what we did. So we had this Go application or Go binary. So we have containerized it. So we have this Docker image, let's say, and we have pushed that Docker image to Docker Hub, right? And now that the image has been pushed, we are going to create a deployment in this Kubernetes cluster, providing this particular Docker image. And it simply means that the program that we were running on host machine earlier is now going to run inside Kubernetes cluster as a deployment, and that is what we wanted to achieve. So let's see if the image has been pushed. So if you see here, this image has been pushed. Now what I'm going to do is I'm going to create a deployment, kubectl create deployment. Name of this deployment is going to be lister, and image is going to be the image that we have just pushed. And let's have a look into the YAML, and don't actually create the manifest. So if we just go ahead and try to have a look into lister.yaml, this is what we expect, right? So this deployment is going to run containers with this specification, and we have specified the image to be lister and with this particular tag. Now if I just go ahead and try to create the deployment in default namespace, so create -f lister.yaml, we should be able to see this pod being created here, as you can see. And as soon as the pod is created, the command that we have set in the Docker file as entry point is going to be run. So as soon as the container is running, or the pod is running, this is the command that is going to be run, and we would be able to, or we should be able to see the output uh, of these these source statements that we have written here. And as you can see, it says crash loop back off. Let's go ahead and try to figure that out. So if you see, it says no such file or directory. It simply means that our program is trying to read data from or read a file at this particular location. If you remember from the previous videos, we can either provide a flag to our program that specifies kubeconfig file, or this program is going to read the file from this default location. And the error that we have here, it says that there is no file at this particular location, and the reason is, when a pod gets spinned up, that pod is entirely different from host machine. So there is no relation between the pod that is running on our Kubernetes cluster. This Kubernetes cluster can be anywhere, and the kubeconfig file is present on the host machine. So now that we have moved the application inside Kubernetes cluster, our program is not able to read this kubeconfig file. So to resolve this, what can be done is, there is this another method that can be called to get configuration while running inside cluster. So for example, let's say if we try to build the config by looking at the kubeconfig file at this particular location, but if there was an error, what we can do is, we can go ahead and try to call in cluster config method to get the configuration while the pod is running inside cluster, and we are going to look into that in just a bit. So this is the package that we are going to use. So from client go and rest, and the method name is in cluster config. So it simply, what it does is, if you remember from one of the videos where we talked about service accounts, we know that whenever a pod gets created on a Kubernetes cluster, a default service account gets mounted inside that pod, and that service account is going to be used now to talk to the API server, because we will have to specify something, some details, some authentication details to talk to Kubernetes API server. When we were running this application on host machine, we specified kubeconfig file, but now we are inside a pod where we don't have kubeconfig file. So we are going to use rest.inclusterconfig, and inclusterconfig is going to look at the path where service account gets mounted at, and that is, we are going to look into that in just a bit. So it returns config and error. So we are going to say config colon error, and if error is not equals to nil, we are just logging, let's say printf error getting in cluster config. Okay, and the error is this. Now we should be able to, now we should not have at least this particular problem, because as I said, in cluster config reads the details from the path where kubelet mounts the default service account. And if you remember, this is the path where kubelet mounts the things. So var run secrets and Kubernetes IO service account. So if we run any pod, this is where default service account gets mounted at. And as you see here, in cluster config uses this same location to authenticate client or authenticate our program against Kubernetes cluster. So now let's just go ahead and try to first let's delete our deployment that we have created, and let's build it once again. So go build, and as soon as the new binary is built, we are going to run docker build once again. So, and let's name it 1.1, and now it should at least be able to talk to Kubernetes API server by using service account tokens. So we will have to push it as well. So docker push or tag first, and then docker push. While it's being pushed, let's just go ahead and try to discuss this in a bit more detail. So let's say we have this Kubernetes cluster, and this was the host that we were using earlier in one of the previous videos. So when we ran our application from this host, we had a kubeconfig file at home/.kube/config, and that is the reason our application was able to talk to Kubernetes API server. So this is, let's say this is API server, but we have now containerized this application, and this application is running as a pod in this Kubernetes cluster. So when the same application runs as or inside this pod, this application is not going to get default kube config, and that is the reason we were getting that issue at the very first place. Now what we have done is we have modified this application in such a way that it is going to use in cluster config method to use the service account that gets mounted inside the pod to authenticate against API server. And in cluster config method that we have just seen does just that. It uses the service account, default service account that gets mounted to authenticate itself or authenticate the application against Kubernetes API server. So now that it has been pushed, what we can do is we can just go ahead and try to update the lister.yaml to refer to new image that we have pushed. And let's just go ahead and try to create the deployment once again. And if we have a look into the logs, it is still being created. We should not have the earlier problem, that is I think we were getting panic. Yeah, so we are still going to have this problem, but we should not have this. Okay, so here we go. If we say get me logs of this particular pod, it says that kube config file was not loaded. That is expected, that is totally fine, because in main.go we have written that if we were not able to form config using kube config file at this location, print this error, right? And then we called in cluster config, and it looks like in cluster config was successful because we are not getting this particular error message. But we are getting pod is forbidden, cannot list resource pods in API group, and the reason is, I think you should be this error message should be familiar to you, and the reason is, as I said, now our application is using the default service account that is mounted inside a pod to talk to API server. So that is the reason it says default service account from default namespace is not able to list pods. Similarly, it's not able to list deployments. So what we can do is, don't worry about crash loop back off. We can discuss about this in a bit, but let's just go ahead and try to create role and role binding in such a way that default service account should be able to list deployments and pods. So kubectl create role named allow named pod and deployment. So resource is going to be pods, comma deployments, and verb is going to be list. So this should work. Okay, so as you can see here, we have created the role, and this role allows access to pods and deployments from default namespace. Now what we are going to do is we are going to create role binding. If you are not confident about these things, I have already created a video about RBAC in Kubernetes, so I think you should check that out. So create role binding named pod deployment, and this is going to attach role, this role with service account default from default namespace. And as you can see here, this role binding has been created. Now if I go ahead and try to have a look into the log of the pod once again, if this pod gets run again, it should be able to list the pods and deployments. Or let's just go ahead and manually delete the deployment and we would create it again. Okay, here we go. So as you can see here, we are able to list the pods from the namespace, and we should also be able to list the deployments as well. I have not formatted it well. So here we go. Deployments are, and name of the deployment is listed. So I think this should make sense. What we have done is, we have configured our application to use the service account that gets mounted in every pod by kubelet to authenticate the application against API server. But we have also, in the video where we discussed about service account, in that video we have also discussed that the default service account doesn't have a lot of privileges, doesn't have a lot of rights. So that is the reason we created role and role binding, and we associated this service account with this role using the role binding. And the role that we created just allowed a list of pods and deployments. So I think this should make sense. If you have any question, just let me know in the comments. I would be happy to answer them. So this is how you can use rest.inclusterconfig to configure your application in such a way that it can run inside your Kubernetes cluster as well as a pod. Now you can have this configured in any way that you want to. For example, you can check if you are inside a cluster first, and then you can try to, and then if there is an error, you can try to figure out kubeconfig file and things like that. So I think, yeah, I think this should make sense. As I said, if you have any question about this, just let me know in the comments section and I would be happy to answer them. Yeah, this is pretty much it, what I wanted to talk about in this particular video. If you like this, maybe you should like the video, share it with friends, colleagues, follow me on Twitter, and I'll see you in the next one. Thank you.